Oh, hello. Welcome back to the Three Laws of Motion by Sir Isaac Newton. So this is Andrew. So just a couple seconds ago, we just went over the first law of motion. And time for the second law of motion. Because the second law of motion comes immediately after the first law of motion, but before the third law of motion. Get it? See, 1, 2, 3. It's not 2, 3, 1. It's 1, 2, 3. Okay, I'm just doing. It's not supposed to be a math thing. It's supposed to be a science project. So the second law states that the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force is the same direction as the net force and is inversely proportional to the mass of the object. Or in equation for its acceleration is directly proportional to the net force divided by mass. So basically, it's saying that the mass and weight also apply to the inertia of an object. Like before Isaac Newton, like in Aristotle's day, people thought that heavier objects fall quicker than lighter objects. As we see, they both fall at the same time. So that's false. But even though that, it doesn't really prove Isaac Newton's thing. So he decided to push two balls of about the same mass and weight together. This is a Fisher-Price plastic baseball and it weighs 78 grams, while this is a Wilson soft level and softball that weighs 159 grams. So now let's do it. So this is Isaac Newton's second law of motion in demonstration form. So as I said before, this weighs less than this one. They're both about the same. They're about the same size and probably about the same mass, but different weights. So I'm going to push these things about the same force. So force is not the only thing that determines an object of inertia, also the mass and weight. So I'm going to gently push these about the same force. 1, 2, 3, 4, 5. So you just saw that. Even though I gave them both about the same amount of force, which wasn't really that much, the Fisher-Price ball went more farther than the softball, because since this one weighs less, the heavier softball had more inertia. As I said before, inertia is the resistance of an object's change in force. So because this one was heavier, it said I have better mass, I don't want to be moved. While this one had a lesser mass and weight, so it didn't have that much inertia. So when I pushed it, it had basically no choice but to going a little farther. Say the inertia was a little less, so it was a little harder for it to stop. They both eventually did stop by gravity, but this one stopped before that one. Well, so that's the second law of motion by Isaac Newton. Time for the third law.